part 3 of our for loop series, and we're going to be looking at how we sum and count in loops, and we're also going to look at a prime example. So let's start with the sum and the count. Let's take an example where we want to display the multiples of 4. Now, for those of you who've forgotten your maths, what is a multiple of 4? Well, a multiple is a number that may be divided by another without a remainder. So, for example, 15, 20, and 25 are all multiples of 5. Why? Because 5 can go into those numbers and there won't be a remainder. So like 5 can go into 25 and there's no remainder. So if you've forgotten, mod is what we use to determine if there's a remainder or not. If I said 24 mod 5, there would be some sort of remainder, something that's left over. So that's what we're going to be using to try to determine if something is a multiple. So let's just get into the mathematics. If I want to check if 1 is a multiple of 4, obviously it's not, but if it was, we would say 1, how many times does 4 go, or does 4 go into 1 without a remainder? That's basically what I'm saying. 4 go into 1 without a remainder. It doesn't, because there's going to be a remainder of 1. But if it was, we would display the 1 if it was a multiple of 4. But in this case, it's not. And then like we would check a 2. If does 4 go into 2 without a remainder? And if it was, we would display the 2. But it doesn't. It's not a multiple. And so on. Like if we got to 4, there we go, 4. Does 4 go into 4 without a remainder? Yes, it does. So 4 is a multiple of 4. So then we would display 4. So that's basically the gist of what we were doing. We would display 4 because this is a multiple. We finally found one. Okay, now what happens if I want to display all the multiples of 4 from 1 to 100? Okay, so 1 to 100. So in this case, we're going to do we're going to repeatedly be doing what we are doing, but we're going to be doing it 100 times. So we put a for loop around, we go from 1 to 100, and we are checking for multiples of 4. But I'm not checking if one is a multiple 100 times. I'm checking if 1, 2, 3, 4, up until 100, those numbers are multiples. And that variable that's going 1, 2, 3, 4, that's my for loop variable. So I'm checking if R mod 4. So it's going to be a 1. Is 1 a multiple? Is 2 a multiple? Is 3 a multiple? Is 4 a multiple? That's basically what I'm doing. And if it is, then we must display R. So let's take R becomes a 1. Is 1 mod 4? Does 4 go into 1 without remainder? No, so let's try 2. No, that's not a multiple. 3 is not a multiple. Go 4. Does 4 go into 4 without a remainder? Yes, it does. So in other words, we have found a multiple, so we must display R, which is 4 now, and then we display the 4. And then we would keep going to 5, and then 6. No, that's not a multiple. And then eventually you get to 8 and display 8, and so on. And so you display your entire list from 1 to 100 of all the multiples from 1 to 100. So only if it's 4 can divide into that number without a remainder will it be displayed. So that's basically what we're doing there. Now, what happens if we want to count how many numbers are multiples of 4 between 1 and 100? We want to count how many there are. Well, then not only are we displaying when we find a multiple, but we need to count them. And so I'm going to have a count variable, and I'm going to increase it by 1 every time I found a multiple. That's why I've put it inside the begin and end of the if statement. So when I find a multiple, display it and increase the count by 1 because we found one. So every time it finds one, it'll increase count. It'll add 1 to it, which is fantastic. So we increase this R count. We can say, hey, R count. When we find one, add 1. But the very first time it does this, it poses a bit of a problem. It's going to say add 1 onto R count. But what is R count starting value? It doesn't have a default value. And if we don't set a default value, it could just give it a random memory block which has some sort of random number in it. And so our value will not be correct. So what should it start off being? When we start counting, before we even start counting, we assume that we've got no multiples, so we should probably set it to 0. And that's what we call initialization. We must initialize our count variable to a 0, to a starting value in this case. It doesn't have to always be 0, it depends on what your scenario is. But in this case, you must give it a starting value. Whenever you are adding onto a value, increasing something, you must initialize it outside of the loop. Before the loop starts, we give it a default value of 0. And then whenever we go through the loop, we then increase 1. So whenever you are counting something, make sure that you are obviously increasing your count variable inside your loop. But before that loop starts, you must initialize iCount to its default value. In this case, a 0. Okay. So it'll start off being 0. So when we find the first value, it'll take that 1 and add it onto 0. So we found the 4. And then when it finds the 8, it found another multiple of 4. It'll then take another 1 and add it onto it. It'll become a 2, and so on and so on. And it'll keep counting all the values. And then after the loop, we can display, hey, there are so many multiples of 4. Obviously, you can only do it once you've counted everything. Okay. Now we've counted them. Now what happens if I wanted to add up all the numbers? I want to take that 4 plus 8 plus 12. I want to add up all the multiples of 4 between 1 and 100. Well, then we are summing, we are adding on. So basically we're going to take a sum variable and we're going to add r onto that sum variable and make that the new sum variable. So that's what we're doing there. We are basically increasing it, but we're increasing by r sum. So take our sum, take what's currently the new value of our sum, or the current value of our sum, sorry, and add r, and that becomes our new value of our sum. So that's what we're looking at. We're taking the value and adding it onto itself. So our sum, let's say we find our first multiple of 4, which is going to be 4. So we're going to add r, which in that case would have been a 4 when we find it. So only when we find a multiple do we do the r sum equals r sum plus r. Take that 4, that r, and add it onto our sum. But remember, with the count, we had to have a default starting value. Same thing with whenever you, not just adding 1 onto a value, when you are changing a value, changing itself by a particular value, you need to initialize it. So we need to remember to initialize our sum to a 0. So that the very first time, when it adds on the 4, it's going to add 4 onto 0. So our sum will be a 0, then it starts the loop, it checks for 1, checks for 2, checks for 3. 4. 4 is a multiple. Display 4. Now add that 4 onto our sum, which is currently 0. So now our sum is now a 4. Then it will check the next value, a 5, and a 6, and a 7. Those are not multiples of 4. It gets to 8. 8 is a multiple. So we must just add r, which is 8. Add 8 onto 4. It becomes a 12. And that's how we keep adding on until it gets to 100. It keeps adding and summing all of those multiples. Let's try that in this example where we're going to find all the numbers with a 7 and a 4 as a common factor. Okay, so that means those numbers can go into it. Okay, so if the number, like for example, 1, can 1 be divisible by 7 and by 4 at the same time? That's what we're looking for, common factors. So 7 goes into that value. So we'll check 1. Can 7 go into a 1? No, it can't, so it won't do anything. But if we get to 7, 7 can go into 7, but 4 can't go into 7 without a remainder. But maybe we find another number, maybe like 28. 7 can go into 28 and 4 can go into 28 without a remainder. Then we display it. So it's basically displaying all the values that 7 and 4 can go into. So let's have a look. Let's see what it does whenever we run it. So this program looks slightly different to the one we did in the example. It's just finding all the values where a 7 and a 4 can go into it. 7 and 4 can both go into 28 with no remainder. 7 and 4 can both go into 56 without a remainder. And 7 and 4 can both go into 84 without a remainder. Fantastic. Now, if I was counting how many there were, let's say we were going to go from 1 to 1,000, for example, and I want to know how many there are, then I'm going to need some sort of count variable, which I will set at the top. And what did we say let's always do? Whenever we find one of these values that we're looking for that's divisible by 7 and divisible by 4 without a remainder, then we must increase that r count value. Increase it. Add 1 onto it. But when it finds the first value, it increases by 1. But add 1 onto what? We don't know. We need to initialize our count. Give it a starting value. In this case, it'll be a 0. And then once the loop is finished, then we can go, okay, we can say show message. And we can say there are plus r count plus numbers. Just in a show message displaying how many numbers there are. But remember, our count is actually an integer, so we must convert this from an integer to a string. There we go. So this is just going to display how many numbers we found. So when we did just to 1 to 100, we found there were 3. Let's see if it finds. So remember, we set count to 0. Whenever we find one of the numbers we're looking for, we increase count, and then we display it. So always initialize your counting variable, increase it by 1, and then display it after the loop. That's normally the order. So let's go. So when it's 1 to 3, or 1 to 100, sorry, up, there are 3 numbers. Fantastic. And what's easy is I can change it to 1 to 1,000, and look what I can do. It's going to find all the numbers from 1 to 1,000. How many are there from 1 to 1,000? A lot more. There are 35 numbers. So we just saved ourselves a lot of time having to count all of them because it's counting. Great. Now, what happens if I want to add up all of the values that are divisible by 7 and by 4 at the same time? Then I'm going to need some sort of sum variable. The sum variable must be whatever you are summing. In this case, the integer, so I can make it an integer. If I was summing real numbers, then you would have to make that real. And whenever we find a value that's divisible by 7 and by 4, we can take the sum value, take what is currently in the sum value, and add r to it. Take that r, add it onto our sum, and put it into our sum. Okay, so it's going to come take the value of our sum, add on the 28, and that add it to our sum. And then it's going to take the next number, which I think was a 50 something, add it onto that 28 and make that the new r sum. But if we keep adding onto our sum, it needs a starting value. So what must we do? Yes, you said it correctly. Initialize our sum to a 0. And then we can just do some sort of display message at the end where we can say the sum is, and we're going to display the sum of all the numbers. Terrible writing it. You don't need to put anything afterwards. Let's just delete all that. So we initialize sum before the loop. We add on values onto sum inside the loop for whatever we're looking for. And then at the end, we say we display whatever our sum is. In this case, we can display the count and the sum. So if we go from 1 to 100, we know there are 3 numbers, and the sum is 168. So if I add those numbers together, that should give me a total of 168. Fantastic. And if I change that to 1,000, there we go. There are 35 numbers, and the sum is a really big number. Fantastic. Let's look at a prime example. We want to determine if a number is a prime number. Now, what is a prime number? A number with only 2 factors, 1 and itself. So it only has 2 factors. So 5, for example, is a prime number because the factors of 5 are 1 and 5. Okay, so 12 is not a prime number because the factors is 1, 2, 3, 4, 6, and 12. So there's definitely more than 2 factors there. So if you remember, the fact is you take the number that you check in. I'm checking if 12 is a prime number and checking all the numbers from 1 till 12. So 1 and 2 and 3, and checking if that goes into it without a remainder. So we're checking the factor is the number that we're checking into the 12. Checking if 3 is a factor of 12 and so on. So that's what we are doing. So for example, we are checking if our number is a prime number. We want to check if 1 can go into our num without a remainder. And then if it is, then you obviously need to increase some sort of count that's counting the number of factors. Okay, so and then we would check if 2 is a factor of our num, and then 3, and then 4. We would continue doing this. Okay, 3 and so on. So we want to check all the numbers from 1 until our num. We don't need to go beyond our num because if I'm checking all the factors of 12, I definitely know that 13, 14, 15 onwards will never be factors of 12. They can never go into it because they're bigger than 12. But all the numbers below that number are possibilities. So that's why we go from 1 till whatever number we are checking. So if I'm checking if 91 is a prime number, I need to check all the numbers from 1 to 91. So we're going to have a loop that goes from 1 to whatever the number is that we're checking. Going 1, 2, 3, 4. And we're using that r variable, that r. That's a 1 and a 2. We're checking if that 1 is a factor, that 2 is a factor, that 3. So instead of checking 3 is a factor from 1 to r num, we're going to check if I is a factor of r num. So from r will become a 1. Is 1 a factor? Then r will become a 2. Is 2 a factor? And so on. And every time we find a factor, we're going to increase the count. Okay, so, but remember, whenever we're doing this, remember we learned when we're increasing a variable, we must initialize it outside of the loop. Before the loop, we set our count factors to a 0. Okay, so it starts off being a 0. Fantastic. Now, so let's take an example. Let's say we're looking for our num is a 5. We want to check if 5 is a prime number. So r is going to become a 1. And then we're going to say, okay, is 1 does 1 go into 5 without remainder? Yes, it does. So we must increase our count fact, which means we increase by 1. Take 1, add it onto that 0. It now is a 1. Right, now we check 2. Can 2 go into 5 without remainder? No, it can't. Can 3 go into 5 without? No, it can't. Can 4 go into 5? No, it can't. Can 5? Yes, 5 can go into 5 without a remainder. That's great. There's no remainder there, so therefore we increase our count. So we take that 1, add 1 onto it, so it becomes a 2. And so then we are now at the end of the for loop. We don't have to check any other numbers. We're done. So now our count is a 2. Now what do we do after the for loop? Well, we're going to go after the for loop, if our count is a 2, then there were only 2 factors, then our number is a prime number. Then we do what we need to do in the event that you found a prime number, whether it's display it or whatever you want to do. And if it's not equal to 2, then obviously you do what the code is that needs to be done if it's not a prime number. So let's go have a look at this in Delphi. Okay, so here we've got a button over here where we clear the memory control and we get in a number that we want to check if it's a prime number. So I'm going to do a loop for r. I've got my r variable already declared at the top there. From 1 to, where do we want to check? We want to check until r num. So if they give me a 51, I want to go until 51. If they give me a 3, I want to go up till 3. That's all I want to do. I'll put my begin and end there, and that's the end of the for loop. End of the for loop, just so I know what's there. So what am I doing? Every single time I'm checking if something can be divisible into r num, which means I'm going to use mod. I'm going to check if r goes into r num. And if it's a remainder, if there's no remainder, then I have found a factor. Fantastic. If I found it, then I'm going to increase some sort of count variable. I've got a count variable there, which I didn't call it r count factor, it's called r count. So I'm going to increase r count. Every time I find a factor, increase r count. But whenever we increase something, what should we do beforehand? Yep, you heard, you must initialize our count. What are we going to set it to? What was the start of being? Well, we've got no factors when we start, and then when we find them, we add onto it. So give it a default value of 0. And when we find one, add 1 on. So it's going to run this loop. That's the end of my if statement. End of if. Okay, great. And then once the for loop has finished, you see, once the for loop is finished, I can say if our count equals a 2, then show message, or whatever we wanted to do. I'm going to say show message. I'm going to show message the word prime. Okay, and if it's not equal to 2, then obviously it's not a prime. So what do we want to do in this case? To say begin, end, show message. What was that? Not prime. In small letters. It's not Optimus Prime. There we go. So if there are 2 factors, display the word prime because it's a prime number. If it's not 2 factors, then it's not a prime. I'm going to make this capital letters, Optimus Prime. There we go. Okay, so let's run. Let's see. So we display 51. It goes not prime. Okay, so let's see if we take in a 5. I know 5 is a prime number. It says it's prime. And if I say I know 12 is not a prime number, not prime. Just to be sure, we can actually display all of our factors here. Whenever we find a factor, we can display it in the memo. Just so we can see if we write lines.add. We are displaying into string r. We're only displaying this whenever we find a factor into toString, list along. Whenever we find a factor, not only count it, but display it so we can see how many factors there are. So when I display a 5, you can see that there are only 2 factors, and that's why it's prime. But when I display a 12, you can see there are lots of factors, and that's not a prime number. And so why is 51 is not a prime? Because it's got lots of factors. Okay, so that's why 51 is not a prime number. And 53, I don't know if 53 is a prime number. Let's have a look. 53 is a prime number. It's only got 2 factors. So there we go. That's how you find prime. So remember, whenever you add in on to a value, whether it's adding 1 or adding onto a sum, remember, before the loop, you initialize the value. Inside the loop, you add onto it by either increasing it or taking its own value and adding onto it. And then outside of the loop, once the loop is completed, then you can display that answer. For the other videos in this video series, go to our YouTube channel, follow us on Facebook, like us on Twitter, subscribe to our YouTube channel. We'd love to hear your feedback. And remember, don't do it the long way, do it the Mr. Long way.